So hello learners. So in this particular session, we'll discuss about continuous knapsack problem and a coin exchange problem. Continuous knapsack problem is also known as a fractional knapsack problem. So what is this problem that we'll discuss in detail? Another problem that is being discussed in coin exchange problem. So both of the problems will be solved using the greedy approach that we have already discussed in the previous session. So starting with this, first of all, what is a fractional knapsack or a continuous knapsack? So one and the same thing. There is another knapsack that is knapsack problem that is referred to as 0-1 knapsack problem. There you can only add the object as a whole, but here in this particular problem you can add the fractions of the object. So I'll tell you when I will go more into the detail. I'll tell you about what do I mean by this. So again, it's a popular mathematic problem that falls under the category of greedy algorithms. The problem involves a knapsack. So knapsack is like a basket or a bag which has a certain capacity that will be given to you, and a set of items with the different weights and values will be given to you. So the goal of the problem is to find the optimal set of items that can be packed into the knapsack in such a way that the total value is maximized. Suppose same thing, that if you are given X number of objects in the candidate set, so you have to add from that candidate sets, you have to add the input to the solution set such that it leads to a feasible result. So as simple as that. So again, fractional knapsack is different from a 0-1 knapsack problem. So there is another problem that is 0-1 knapsack problem. So what happens in 0-1 knapsack problem is that where an item can either be included in the knapsack completely or not included at all. So in fractional knapsack, if you are given a choice that you can suppose you have to put the mangoes in the knapsack. So if you are given a choice that you can add half mango, you can add it. But in 0-1 knapsack, you either have to add the whole mango or not at all. Okay. So if by adding the whole mango it is leading to an infeasible solution, you can directly ignore it. But in fractional knapsack, you can add fractions of that mango. What do I mean by this? You can add 1/4 of a mango, 1/3 of a mango, 1/2 of a mango. So depending upon it. Okay. So the difference between fractional knapsack and 0-1 knapsack is that, keep that in mind, that fractional knapsack you can add half or fractions of the items, but in 0-1 knapsack you can only add the items as a whole, or you cannot add the item at all. Okay. So formally, if we discuss what is a fractional knapsack problem. So suppose you are given a list of n items or objects, say I1, I2, I3, I4 until you get the In. So n will be the number of items here. Okay. So I1 is one item, I2 is another item, I3 is another item, up to you can get In. So n says that the number of items, like 4 items, that n will be 4. So there are 4 items, and a bag or a knapsack. So the capacity of a knapsack is given in the variable m. So m represents the capacity of a knapsack. Now each object I or each item I has a weight and a profit value that is assigned to that object. Okay. So what do I mean by this? That if I say item 1 has 2 kg of weight and will get me a profit of 100 rupees. So that will be a profit value. Now, if the fraction xi of an object I is placed in the knapsack, then a profit of pixi is earned. So what do I mean by this? That You can also add fractions of an object, and how to calculate the profit, that will be depending upon the calculation. So what do I mean by this? Like if there is 2 kg of weight, 2 kg of weight have 100 rupees of profit. So you are not adding 2 kg, but you are only adding 1 kg. So what will be the profit according to 1 kg? So that will be calculated and added in the value. So what do we mean by this? If 2 kg is giving you 100 rupees, 1 kg will give you 50 rupees of profit. So that is how. So if you are fractioning the item, the profit will also be fractioned based on the fraction that is being done in the item. Okay. So if only the half item is being added, so you can take the profit by half. If 1/3 item is being added, so the profit will also be 1/3. Here, if you talk about the objective function of the knapsack problem, so what is the objective function here is that you have to fill up the knapsack up to its maximum capacity, that is the capacity that is given in the variable m, which maximizes the total profit earned. So our main task is to maximize the profit in this one. Okay. So mathematically, if you see here, mathematically the profit will be given as pi xi, which will be subjected to some constraint. So the constraint will be the total weight of wixi should be less than the capacity of the knapsack, where I belongs to the constraint that the value can be dependent upon the number of items. So I can be from 1 to number of items n. So if there are 4 items, so I can be 1 to 4. Okay. So moving on forward, now take the example that how to understand the problem of a knapsack. So what we are doing is that we are taking 3 objects and the capacity of the knapsack is given as 20. The profit P1, P2, P3 that is being associated with each object or each item is given as 25, 24, 15, and then the weight is given as W1, W2 and W3, which is 18, 15 and 10. Okay. So now check. There are 3 strategies with which fractional knapsack works. First strategy is that you have to select the object which gives you the maximum profit. Next strategy is that you have to select the object that gives you the minimum weight. Next is the strategy which is mostly followed is that you'll take the profit by weight ratio. So profit by weight ratio of all the objects or the items that is given, whichever profit weight ratio is higher, you will add that item first. 3 categories, 3 strategies that is given there. So now I'll discuss the solution here. Okay. So the problem was saying that you will be given a number of objects, that is 3. Then you will be given the capacity of a knapsack, which is 20. Then you will be given 3 items with 3 weights and 3 profits. So first approach is to check that the object with maximum profit is being added first. Okay. So 3 x1, x2, x3 are the 3 objects. So if you check here, with which object the maximum profit is being assigned, the object 1 has the maximum profit of 25, 24, object 2 and 15, object 3. So the maximum profit that is being there is 25. So you take that particular object, put it into the knapsack. So what is the weight of that? So the weight of that is 18. So when you added that object into the knapsack, so the capacity of the knapsack was 20. So when you added, only 2 capacity is being left with the knapsack. So you are completely adding the object 1. So you are putting 1 in front of x1. Now the remaining capacity is only 2 in the knapsack. So another object, now what is the maximum profit after 25? It is 24. But you cannot add, what is the weight associated with 24 is 15. So you cannot add 15 completely to the knapsack because the remaining capacity that is being left is only 2. So what you do is that you take the weight, only 2, and you calculate the fraction of it. So what do I mean by this is that how much you can suppose it's a 15 part that is being there. So 15 parts of item 2 will give you a 24 profit. Okay, so what we are doing, we are not adding 15 parts, we are only adding 2 by 15 parts of the item, and will include the 2 capacity remaining in the knapsack. So now the third item will not be included because it is already, the capacity is being full. So the maximum profit that you will be able to get out of it is firstly you will get the complete profit, that is 25. The next profit is again that you have added only 2 by 15th of the element. So what you do is you take the 2 by 15th of the profit of P2. So it will be 24 2 by 15. So it is only 3.2. So when you add it, you will get 28.2 profit to profit ratio. Maximum profit that you will get with adding first the items which has maximum profit. So the second strategy is that you add the object which has a minimum weight. Okay, from the weight category which has the minimum weight. So the weight is item 1 has 18 weight, item 2 has 15, item 3 has 10. So item 3 has the minimum weight of 10. So firstly add item 3 to the knapsack. So by adding item 3, so you write x31 first, that first item is completely added. The third item is completely added. So you write 1 in front of x3. And now when you add it, the remaining capacity is 10. Now the next weight is either 15 or 18. So item 2 is 15, item 3 is 18. So what you do, you add item 2. So when you add item 2, you cannot add item 2 fully because you have a remaining capacity of 10 and item 2 capacity is 50. So what you do, you again take the fractions of it. So you're only adding 2 by 3 of the item which has the capacity 10 and it is fully exhausting the knapsack limit, that is 20. So now check here again, calculate the profit ratio. So what will happen here is that you will get the item 3 profit fully which is 15, and you will get the remaining item which is 15. You will get the fractional profit of the item 15. Okay, so if you calculate it, it will be 31. Similarly, for the third approach, which is the best approach in this example as well as mostly followed approach, if you check here, that is profit by weight ratio. Okay, so what do I mean by this is that first take the profit 25 divided by 18. Next item, take the item 24 divided by 15. Next item, take the item 15 divided by 18. So what you will get by dividing 25 by 18, you will get around 1.3, and by dividing 24 by 15, you will get 1.6, and by dividing 15 by 10, you will get 1.5. So which has the maximum profit by weight ratio, which is item 2, which is 1.6. So you include the item 2 fully first, then the remaining item will be included. So another one is item 3, which has a profit of 1.5. So it will be included based on the weight. So it is not fully added, because when you add the item W weight with having weight 15, that is item 2, you will only left with a capacity of 5. Okay, so based on the capacity of 5, you will again add parts of that item, which will be depending upon that. So 5 by 10 will be 1 by 2, so you will add 1 by 2 of the item, and similarly you can calculate the profit. So you see here the maximum profit that you will get here is 31.5, which is again gotten by the solution of the third approach. So the third approach is that if you certainly get the profit by weight ratio, you most probably will be able to get the maximum profit in this particular case. But you mostly profit by weight ratio is the feasible solution in most of the solutions. So greedy approaches do not always yield. So these three approaches will not always yield optimal solution. In such cases, the greedy method is frequently the basis of a heuristic approach. But approach 3, that is selection of the object based on the profit by weight ratio, always gives the optimal solution for the knapsack problem. So in context of a knapsack problem, the solution will of profit by weight will be the best one. So this is the algorithm that is being given of a greedy fractional knapsack problem. If you check it, so firstly you will be provided with the function greedy knapsack, and there will be an input of p, w, x, and m. So these are the variables that will be inputted. So p and wi will be the profit and weight, xi will be the solution set, and m is the maximum capacity of the knapsack. Okay, so firstly start with the loop that initialize the variables. Xi variable will be initialized, then profit, then weight, and then start with then start with another loop that says that when the capacity of the knapsack is not reached, so what you do, you just add the weights that is being selected with the method like profit by weight or any of the three approaches. Now what you do, you add the weight with the wi. If it is less than the capacity m, then you will add that item completely and you will add that weight into the knapsack. But if it is not less than it, so you will add the fractions of it. So what do I mean? If it is not, else part will be executed. Now x will be m minus weight, and then it is by w, will be divided by the weight of I. So it means that you are adding the fractions of this item into the knapsack. Now in the end, that weight will become L, and you will add the profit, and in the end you will get the profit based on the method. So this is a simple algorithm of fractional knapsack that is being followed. Now another problem that also came under greedy approach is the coin exchange problem. So again, coin exchange problem is following a greedy approach. Like firstly, you will be given a candidate set, and based on that candidate set, you will take the value. You will take the input from the candidate set. You will check it for feasibility. If it is feasible, you add that particular input to the solution set. Okay, partial solution set that mostly we call. Okay, so the coin exchange problem also be approached using greedy algorithm. Greedy algorithm is one that makes the locally optimal choice at each step, with the hope that this will lead to a globally optimal solution. Okay, so in this case of the coin exchange problem, the greedy approach involves repeatedly selecting the largest coin denomination that is less than or equal to the remaining change. So you will be given a set of coins denominations, and based on the denominations you have to get to a goal. Like if you will be given a particular number where you will be going to get. And again, say following the same thing, that if you check the problem, if it is feasible, add it to the solution set, so on and so forth. So what do I mean by this is that, so the example here is that you are given Indian currency notes, 1 to 5, 10, 20, 50, 100, 500 and 1000. And the problem is to find, so this is coin exchange problem. The problem is to find the minimum number of currency notes to make the required amount A for payment. Further, it is assumed that the currency note of each denominations are available in sufficient numbers. So that means that like 100 can be repeated any number of times. 1000 can be repeated any number of times. So that one may choose as many notes of the same denomination. So this is the meaning of it. Okay. So you are given a denomination note that you have to get to the solution, that is 289. Okay. So solution is that you have to make minimum number of currency note. You have to make the required amount 289. Okay. So there are only two conditions that will be followed. First condition is that whichever denomination that you are taking should be less than or equal to 289. And if D1 is another denomination of the note such that D1 is less than, then D1 can also be less than D. Okay. So D1 is another denomination of the note. D1 can also be selected. So if they are adding D, it should be less than. And D1 is another denomination of a node such that D1 is less than 289. So what do we mean by this is that if you are selecting another denomination which is again less than 289, that denomination will be less than the previous solution, or it will be equal to the previous solution. So what do I mean by this is that suppose the maximum denomination here can be added 100, because you cannot add 500, because if you add 500 it will become greater than 289. So when you select 100, now the next you can select less than 100, less than or equal to 100, or less than 100. So if you select 100, which is again less than 289, so you can simply say that D1 is also less than 100, less than or equal to 100. So it means you can select 100 two times. Okay. So the solution is again very simple. It is based on the same lines that firstly you will start from the maximum part. Okay. So firstly we'll start with 1000. Now 1000 is greater than 289. So can it be added to the solution set? No, because it is leading to a infeasible solution. So you're going in further with 500. 500 is less than 289? No, 500 is not less than 289. So it will again not be added to the solution set because it is not leading to a feasible solution. So another is your 100. Can 100 lead to 100 is less than 289? Yes, 100 is definitely less than 289. It means that it can be added to the solution set. So what it means is that you add 100. Now, you can either add 100 now, or you can go below 100, which is 50. Okay, you can do that. But again, when you have already selected 100, the condition that it is less than 289 is still valid. Now, if you again select 100, this condition, that is, should be less than 289, will again be added. It's true, because 100 plus 100 is 200, which is again less than 289. So you can again include the 100. Okay. So the condition is only that if it is getting less than 289, only then you can include that. Now third step, again include the 100. Now check the condition, it is less than 289? No, it is not less than 289. So you cannot add another 100 there. Now go with the 50. 50 is again less than 289 because it is becoming 250, which is less than 289. So you can add the value 50 there. Can you add another 50? If you add another 50, it will become 300, which becomes greater than 289. So you cannot add. Another denomination is 20. So add 20. Is this less than 289? Yes, it is less than 289. So it is 270. So you can add 220 here again. So again, can you add 20? No, you cannot add 20 because then it will become 290, which is greater than 289. So you cannot do that. Similarly, go with another denomination, less denomination than 20, which is 10. So again, you can add 10, which is becomes 280, which is less than 289. So it can be added. Can you add another 10? No, because by adding another 10, it will become 290, which is greater than 289. So again, not the solution. So can you add 5 now? Yes, you can definitely add 5 because it becomes 285, which is less than the solution, 289. So you can simply add 289. You can simply add 5 here. Can you add another 5? No. You cannot add another 5 because if you add another 5, it will become 290, which is again greater than 289. So go with another further decreasing denomination, that is 2. Can you add 2? Yes, definitely you can add 2 because it is 287, which is again less than 289. So you can simply add. And then again, can you add 2? Yes, you can add 2 because by the addition of 2, you are leading to your goal state, which is 289. You are seeing here that we are taking the input from the candidate set. We are putting it into the partial solution if it is satisfying a certain condition that the admission of a particular input x not leading the value to be greater than 289. So always we are checking that. So if it is not leading to the 289 part, so we are adding it, otherwise we are discarding it. So this is how the coin exchange problem is being solved. And we have done till now, we in this particular session, we have seen coin exchange problem. We have also seen a greedy strategy for knapsack, fractional knapsack problem, in which we are adding fractions. We have seen that there are three particular parts of that category that you can solve that knapsack problem with, either by selecting the object with maximum profit, or by minimum weight, or the successful always optimal solution that is being provided by the profit by weight ratio. Okay, so in the next session we'll see another greedy techniques. So till now, thank you.